This is lesson part 1.5 on the How to Do Algebra section, and it's for higher students because we're looking at Factorising Quadratics, which is grade B and above, and only on the higher paper. Now, before we start this video, have a look at this expression and see if you can factorise it. So pause your video and factorise it, please. Now, if you found factorising this difficult, then you need to go and look at the part 1.4, which is factorising. Now, what we're looking for here is a pair of highest common factor, where the highest common factor is 4ab, and we can write this then, these two terms as a product pair, which is the same thing. Just like factorising 6, we can split it into 2 times by 3. So we've taken the original number and now we split it into a product pair. We're doing the same now with this number, but it just happens as 2 terms, and we're going to split it into a product pair. So that's that's the highest common factor in these 2 terms. So 4 times by 4 gives the 16. A times by a gives the a squared, and b times by 1 gives the b, so I could write a 1 there, but I don't need to. 4 times by negative 1 gives negative 4, a times by a gives 1, and b times by b gives b squared. So if you got that right, then you're in a good position now to move on to the grade B factorising quadratics. Now, we factorise quadratics to allow us to simplify more advanced expressions, but also to solve quadratic equations, and there's a whole different section on solving quadratic equations, which I will not be teaching people how to factorise. That's this video. So if you're looking to solve quadratics, watch this and then watch the solving quadratics equation video afterwards. Now, let's have a look at this question and see if you can factorise this. 6ax squared plus 6ax plus 2x. Okay, now factorise that, please. So pause your video and factorise. Okay, well, the common factor this time, the highest common factor this time, it's got to be over all 3 terms, is 2x. And look at the previous video for a bit of hints or a bit of help on finding the highest common factor. And now 2 times by 3 makes the 6. A times by 1 makes the a. X times by x makes the x squared. 2 times by 3 makes the 6. A times by 1, and then x times by 1. And then finally 2x times by 1 makes 2x. So that's factored. Okay. So if you multiply that out now, let's just check. Multiply the first pair, we get 6ax squared. Multiply the next, we get 2 3s are 6, and x times by a is ax, and finally the final 2x times by 1 is 2x. So we can confirm that we did factorise it. Now we can factorise that with 3 terms because there was a common factor between the 3 terms. But on this example, okay, this quadratic, we'll see if it factorises this time. And now there is not a common factor other than the number 1. The highest common factor of these is the 1, so we could write 1 outside the front or in the first bracket, but that's not going to do us any use at all. All we've done is rewritten the same question, the same expression, but now we've just made it clear that we've got one of those expressions. So it looks like you can't factorise that. Okay, and what we're going to do now is to look at how we factorise quadratics of this form, because they do factorise, or some of the quadratics are like this form do factorise to give whole numbers, so they factorise nicely. Others don't, and then we'll be showing you 2 other ways of coping with those later on, but for now we're going to look at the ones that do factorise, or may factorise. Now the form of the quadratics that we will see will look like this: ax squared plus bx plus c. Okay, that's the form we'll be looking at. So there could be a whole number in front of the x squared, a whole number in front of the x, and a whole number in front of the c. They're the ones we'll be dealing with to begin with. Now, if you start off with a question like this one, the first thing you do is just see if there's a common factor before you do anything else. So just because it looks like there's an x squared there, and because there is, and it's got 3 terms, it might look like it's one of these. But the first thing you should always do is to see whether there's anything in common to begin with, because if there is, you can factorize it like we did here. So these are the ones that we're going to start off by looking at in this form. Now before we do that though, I've got a little exercise for you to do to see if you can spot a pattern. So I'm going to put up some 5 pairs of brackets, and I want you to expand those brackets and see if you can spot a relationship or a pattern that's appearing in all of those. So once you see the 5 questions, copy them down and then pause the video. Okay, so they're the 4 questions, so I'd like you to expand those carefully. If you can't expand those brackets, then there is a video on expanding brackets or double brackets on the same series. And they're the first 3 done for you, so hopefully you got the same thing when you expanded those brackets. Now, can you spot anything? Look at the answers to the first 3 and see if you can spot anything, and then see if you can generalize it with part of question 4. Okay, so see if you can spot anything. Right, well you may have spotted that the numbers inside the brackets here have a relationship with the numbers inside the quadratic expression here. Now quadratic expression, they're both quadratics, but this one has an x squared plus 2x plus 1, so that's in the form that we wrote before. Okay, now you might have spotted, for instance, that 1 times by 1 gives the 1, 2 times by 1 gives the 2, 3 times by 2 gives the 6. So that's where the number at the end came from, the constant at the end came from. And then the number in front of the x, which is called the coefficient, so the coefficient of x is made up of, well, 1 times by 1 isn't 2, so let's try adding. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5. So the numbers inside the brackets here multiply to make the number at the end, and add to make the coefficient of the x. Now this works when there's the coefficient of x squared, or the number in front of x squared, is 1. Now we can see that in more general terms if we expand the last one. Okay, so if we expand the last one, now you'll see that that's not quite right, not quite finished yet. Now if we factorize this middle bit, so we've learnt to factorize above, so if you forget these 2 terms at the end for now, if you ignore those 2 terms at the end for now, you'll see that it's got an x in common, so we can factorize the middle bit to get a plus b lots of x plus ab. So the number here, a, and the number there, b, add together to make the number in front of the x, and multiply to make the constant at the end. And that's basically the idea we use, but backwards, to factorize quadratics. Okay, there are other ways with grids and things, but I just think to begin with, just keep it nice and basic, keep it nice and straightforward. Now if you want to look at a method for solving quadratics for grids, factorizing quadratics for grids, then I'll probably put that one up in a couple of days' time, or I'll ask another member of the team to do so. But at the moment, this is the method I want to use. So what we're looking for is quadratics that multiply. We're looking for, well, let's just do an example. So let's do the example we started with, x squared plus 2x plus 1. Now that's going to factorize into a pair of numbers multiplied by each other. Okay, just like 6 factorizes into 2 times by 3, we've got to find 2 numbers that multiply together to make x squared plus 2x plus 1. Now it's going to be x, because x times by x will give us the x squared. And now we've got to work out the numbers that go in here. Now looking at this pattern above and looking at this general form, these two numbers will add to give the 2 and multiply to give the 1. So let's start off by writing down the different ways you can make the number 1. Well, you can do 1 times by 1 and 1 times by 1. There's also negative 1 times by negative 1, and then if you turn them round, well, we know that multiplying in different orders gives us the same thing. So they both multiply to give the answer 1. Now this pair adds together to make plus 2, and this pair adds together to make negative 2. So the pair that adds to make plus 2 and multiplies to make 1 are this pair. So it's going to be x plus 1, x plus 1. So we factorized. Okay. It's multiplied together to make the 1, and it's multiplied together, so added together to make the 2, the positive 2. So if we had this example, we're looking for two numbers that multiply together to make 1 and add together to make negative 2. Well, we've got the answer above here, look. We've got the answer is negative 2 for the adding and 1 for the multiplying, and that's going to be x minus 1. X minus 1. So that's basically the method that I want you to use when solving simple quadratics. The simple ones are the ones where the number in front of the x squared or the coefficient in front of the x squared is the value 1. And it comes back from spotting this pattern and looking at this general form. And remember, when we factorize, we're taking the original number and splitting it into a product pair. Okay, now we're going to work through some examples together. So let's do the example together. X squared plus 5x plus 6. We know that's going to go into a product pair, and it's going to have to be x and x, because when you multiply x by x you get the 1x squared there. Now we've got to find the two numbers that go with the x to complete this factorizing. So we're looking for a number that multiplies to give 6, or pair of numbers, sorry, and adds together to give positive 5. So multiplies together to give the 6 and adds together to make positive 5. So let's look at the pairs of numbers that make 6. Well, that could be 1 times by 6. It could be negative 1 times by negative 6, 2 times by 3, or negative 2 times by negative 3. Now if we add these together we get 7, minus 7, 5, and negative 5. So the pair of numbers that give 6 when you multiply them and 5 when you add them is positive 2 and positive 3. So we have factorized that quadratic. Next example then. T squared minus 5t plus 6. Okay, now it's going to go into a double bracket. Now when we were doing factorizing the last video, we started off with a bracket there, but when there was one term in that first bracket there was no need for it. But as there's two terms now, we're going to have the bracket, otherwise we're not going to multiply everything in that bracket by everything in that bracket. Okay, now it's going to be t this time and t this time, so be careful. This quadratic is in terms of t, not x, so I don't want you keeping x there because that's what you're always used to doing. Now we're looking for two numbers that multiply together to give 6, positive 6, and add together to give negative 5. So you have to include the sign there when you're looking. So multiply together to give negative 6, so positive 6 is going to be 2 3s, 1 6, and negative 2 times by negative 3, and negative 1 times by negative 6. They add to make 5, 7, negative 5, and negative 7. Now, when students first do these, they can't find the pair because they forget that you can multiply two negative numbers together to make a positive number. So if that's what you've always struggled with, well, that's easily fixed. Just remember that two negatives do multiply to make a positive. So this case, this is the negative 5 we're looking for here. So we know the answers are going to be negative 2 and negative 3. So t minus 2 and t minus 3. Okay, the rest of it just comes with practice. We're going to do one more together, and then I'm going to let you practice. Q squared minus q minus 56. So q squared minus q minus 56. So it's going to be q and a q. Just don't do x's automatically. We can't change the expression. The expression this time is in q. There's our two numbers multiplying together. Now we've got to come up with two numbers that multiply together to give negative 56, but add together to give negative 1. So they're going to be quite close together, the numbers, because this is a small coefficient here, or the magnitude of this coefficient is quite low. They're going to have to be quite close together, so when you take one from the other it gives you negative 1. So just think about it for a second. What numbers multiply together to get 56? We could do negative 2 and 28, but there, obviously when you add those together it's going to give 26, and that's what I mean about they have to be close together. In fact, we know they must have a difference of 1. And with a bit of experience and a bit of instinct, you can factorise these quite quickly. So we know there's going to be a difference of 1, so when you take one away from the other you get negative 1. And they're going to multiply to give 56. So again, think of your times tables and think about which two numbers which are 1 apart give 56. And you should know that it's 7 times by 8. 7 8s are 56. But because we need negative 56, it's either going to be negative 7 or negative 8. Okay, so negative 7 times by 8 is negative 56, or 7 times by negative 8 is negative 56. So, which pair add together to give negative 1? It's this pair here, because 7 take away 8 is negative 1. So these are the answers. So it's going to be q plus 7 or q take away 8. Now just while we're here, if you put the answer down as q take away 8 lots of q plus 7, that's also a correct answer. Because remember, when you're multiplying two numbers together, and that's what you're doing, you're multiplying these two brackets together. It doesn't matter which order you multiply in. 2 times by 3 is the same as 3 times by 2. So it doesn't matter which order you multiply these in. So if you put the answer down as q take away 8 lots of q plus 7, then yours is also correct. So don't mark it wrong and don't be disappointed. You are getting the answers correct. So it doesn't matter which order they're in. Okay, so there's some examples of factorising the most straightforward quadratic equations, and that's grade B at GCSE. So I'm going to give you some questions to do now, and as usual, you'll get most out of it is if you try and factorise them, and at the end I will show you the answers. So once you've seen the questions and you copied them down, pause your video, otherwise you'll see the answers before you've had a chance to work at them. So here are the 5 questions, and in a little while I'll put the answers up. Okay, and here are the answers. Now, if you've got the brackets around the other way, so you've got x plus 4 lots of x plus 1, or g take away 5 lots of g take away 2, then they are the same answers. But down here you can't change the values. If you've got a negative 3 in here and a positive 6 in here, you have got the wrong answer, because that would have been x squared plus 3n. Okay, so hopefully you got those 5 right. In a future video we'll go on to look at what happens when the number in front of the x squared or the g squared or the quadratic term, the term with the square, is not 1. And one more thing to point out, in your answers, if you have put x's in every bracket, because that's what you're used to doing, then they're wrong. They must match. So n's must be with n's, x's with x's, d's with d's, and so on. Okay?